that presentation. To you live from the ITSEC show floor. And for those of you that don't know what ITSEC is, it's actually the Inter-Service and Industry Training, Simulation, and Education Conference. My name is Bill Reuter. I go by Roto, kind of Roto Reuter, okay? And so I'm a former F-18 pilot and a test pilot. I grew up here in Florida, and I went to the University of Florida, got an engineering degree at University of Florida, and started flying airplanes for the Navy. And so you'll see there's a ton of people around here at ITSEC that have incredible backgrounds that come from places just like you. And so you're going to meet some of those folks as we go on the tour today, and we're going to talk a little bit about what's going on at ITSEC and why that's important to you making decisions about your future. Okay, so I wanted to welcome you and let you know that this event is actually sponsored by the Tech Path program, which is part of the Florida High Tech Corridor Council, and it's also sponsored by the folks here at ITSEC, because it does take a little bit of effort and some money to put this on. So, but you know what? It's all about you and making sure that you get what you need. And then for the educators out there that may be logged in to the webinar, if you have any questions or anything like that, we'll do our best to take them. But the only way to do that is going to be through the group chat or through the text feature in your webinar application. So that's what we're going to do. We're going to go see 3 different places around ITSEC, and we're going to take a little short walking tour around ITSEC, and we're going to give you an hour of what it means to be here with these over 15,000 people and so many exhibitors from all kinds of different things, from medical training to flight training to the kind of training you're going to see here first. So without further ado, we're going to go into our first demonstration of what is called the multi-purpose reconfigurable training system, and this is for the Navy. So I'm going to turn it over to a couple of colleagues of mine and guys that are affiliated with the Navy, and they're going to talk you through what it is they do with this big system that you see in front of you. So go ahead, Dave.
My name is Mark. Hi, my name is Kwavu. I'm a computer engineer. I graduated from Oregon State University, and now I'm a system engineer for the Merc 3D project. And I'll turn over to David.
Hey, good afternoon. My name is David Thomas. I was an aerospace engineering major at Georgia Tech University. Then I joined the Navy, became a submarine officer. Spent 20 years underneath the sea, doing a lot of really cool things, most of which I can't talk to you about. But after that, I now work for the Navy as a civilian. I'm a project manager for the Multi-Purpose Reconfigurable Training System, or MERTS, rhymes with Hertz, MERTS 3D system. And in the Navy, just like a lot of academic folks out there, we realize that you can only learn so much by reading a book or watching presentations, or in the Navy, as we lovingly refer to them as, death by PowerPoint teaching. We realize for a lot of things, especially running around in a submarine torpedo room or flying an aircraft, you learn by doing. And so, but of course, planes are expensive, submarines are expensive, and you don't want to be trained on the actual system the first time you touch something. So we have training simulations. And what you're seeing here is one of our products, the MERTS 3D Virginia Emergency Diesel Trainer. And if you could walk around the instrument for us. Now, your iPads and phones aren't this big yet. So some of the gestures we use to navigate is very similar to what you have for your phones, like 2 fingers to pinch, for example, zooming, that sort of things. But here, we can also navigate by our hands. So if you put up one particular hand, doesn't matter left hand or right hand, you'll see a little cog or gear show up. That way the game or training system knows you're in navigation mode. So you use 1 finger, you can go up, down, left, right. 2 fingers, you're walking back and forth inside the simulation. And 3 fingers, you become a disembodied spirit, and you're able to float around in order to get to a particular valve or whatnot. And running around this system, it may look like you might have seen on various RPG games. Well, that's because this is produced in a gaming engine, just like your PlayStation and your Xbox, or even your iPhone apps. For those who are techies, we use the Unity gaming engine, which makes about 40% of your video games that you're buying on your phone. And we produce a real-world simulation. This is what a Virginia auxiliary machinery room looks like. If you have particular valves or something under the floor on a submarine, they're called a deck plate. We put them in the real place. So this way, a sailor, before he goes to sea, knows where everything is inside the submarine, and we can manipulate things. And also, we try to make it as realistic as possible. For example, say we have a very large valve you can't open with one finger. You put one finger on it, nothing's going to happen. You have to put several fingers or your whole hand on it in order to operate it. And if you go to the drain valve, please. And also, the simulation is physics-based. In other words, the one with the drain. So we develop a system, we make graphics, and the simulation knows that we have water in particular spots and areas. So if we open up a particular valve, we can drain it. We can drain the valve. We can drain the water. And while it's running around looking for it, so we can move on. One more chance. While he's doing that, we can also do maintenance on this area. For example, and what we have is personal protective equipment. So you got foggy because, hey, when you put your glasses on, it's going to get a little foggy, and you can put on your gloves. So that way, we're doing all the same maintenance procedures, kind of like when you're changing your oil or fixing your bike or even opening up your computer. And we can run around and do those sort of things. We can shift to the mobile electric power plant. Also, just like your PlayStation games, you can shift from one application to another on one set of hardware. This saves us a whole lot of money because the older trainers used to have one particular hardware, one computer running only one simulation. Now we can run it all just like your PlayStation and your Xbox games. And if you'll notice, he was able to start this as a mobile electric power plant. Basically, aircraft, you need something to help start them up. And this particular device just provides that power to help start it up before its engines are running. And it sounds just like the real trainer would. And then we're also able to insert faults. And for this particular one, we have the posted procedures because in the Navy, you can't start a plane, you can't drive a submarine, you can do hardly anything, including flushing a toilet on a submarine, without a written posted procedure. So we embed the procedures here inside the trainer. We're able to move it around so it doesn't get in the way. And when you're at home, if you're trying to figure out how to fix your computer, change the oil, whatever, what do? You go to YouTube. So we have embedded videos, a few seconds to a minute, showing on the real device exactly what it looks like. So that way, people are able to repeat what they saw on the video and go do it on the exact same system. And of course, the real world, it's not always as perfect as what you see in a textbook or things. So on this particular trainer, we can actually insert things. We can have an oil leak. We can have cracked glass on the gauge. We can stick something. This is all to make it as realistic as possible. And we always take a look at what is the most common problems we're having. We simulate those problems so that the students, the sailors, the Marines, etc., can learn how to look at those main problems and be able to fix them. You can see the oil drips, flatten the tire, we can do lots of things. And these particular trainers is currently fielded at a variety of sites: Groton, Connecticut, Norfolk, Virginia, Pearl Harbor, Hawaii, Pensacola, Florida. These trainers are all over the country. We even have some trainers way out in Guam. Google it if you're not unfamiliar with that island. So these particular trainers are used by students, and it saves the Navy millions of dollars because these particular devices can cost anywhere from $60,000 to $1 million or to several $1 million for an actual system. We're able to do it at a fraction of the cost.
So you built that inside the Navy, basically?
Yes, right. All the simulations that you've seen were what we call in-house development, meaning the Navy's engineers and some of our Navy contractors helped produce this. However, it became too popular. It was too big for our in-house little lab to produce all the applications that our customers wanted. So we've now got to a contractor. So now there's contractors. You have software engineers, computer engineers, quality assurance folks. You have technical writers who have to write the procedures. Just like you get a brand new Blu-ray player, but you don't know how to run it. There's an instruction manual. somewhere there's a person who had to write that, and that's not necessarily the same person that designed it. So there's lots of people. It's more than just the engineers. And then, for example, the team that produced this, it was about 15 to 18 people, all with different skill sets, all with different college degrees, and different technical training. What you're seeing here is this is a schematic diagram representing what's going on with the wires and electronics and the guts of the electric power plant. And before fixing something, the students can go through and troubleshoot, determine where they think they follow the electricity to where it should be going. And then they can send it to the instructor, and the instructor can then grade the students. And the reason why we use this as a teaching technique is because we don't want the students to just start ripping parts out and try to figure out what works.
Right. That makes sense. Well, cool. So, Commander Thomas, we really appreciate this. It looks as though not only are we, because training on the real equipment costs a lot of money and costs a lot of heartache and that sort of thing, and we really don't have the equipment to do that. So, so now you can simulate all kinds of different equipment that some of which are hard to get, and you certainly don't have some of them available to train on. So now, if you're thinking about this, it costs money to buy all this stuff, and it costs taxpayers money to buy all this stuff. So with the kind of innovation that we have in the virtual reality world that we have at our disposal now, we can actually provide realistic training into these sailors and Marines and soldiers and airmen that give them the proficiency and the confidence and all of that they need when they're working on sometimes multi-million-dollar systems, right? So, well, thanks a lot for the presentation. Really, really appreciate it. And anything final words you want to tell these guys and gals?
Hey, when I was in high school, I wasn't sure what I wanted to do when I grew up. I got my engineering degree. I thought I wanted to design planes. Turns out I rather went the opposite direction and went undersea to be a submarine officer and serve our country and protect the Constitution. So you can have multiple careers. I'm on my second career already. So just think about what you want to do and have a backup plan, and you can have a really great time.
Roger that. Thanks a lot, Dave. Well put. We appreciate it.
Thank you.
You betcha. We'll see you around the campus. Okay, so we are. It's Roto again, and we're going to be in transit to the next demo. And again, we're coming to you live from the show floor. You can see, even if you look around the show floor, you can see all the demonstrations and all of the different things that are available to you. And for those of you that are in schools that weren't able to make the student tour on Thursday that's here in person, we're giving you just a little bit of a taste of what it's like and what it's going to be like for you if you're able to get here next year. So hopefully all of you understand a little bit more about what this is about. We're going to go to a flight trainer next. That's near and dear to my heart, and it's actually a really good friend of mine. He and I were test pilots together. And he is from the Army, and I am, of course, from the Navy. So he's going to be a... Oh, yeah. Sorry if this gets a little bouncy for you guys, but we've got all kinds of things going on in here. You can see as I'm walking through, we're going to see a little bit of medical a little later today, but you'll see these kinds of medical mannequins over there if you can see them in the screen. We're going to be doing that a little later, up close and personal. Some of the gory details of what it really takes to educate medics in the combat field and all of that sort of stuff. So there's a lot that goes on here. So this isn't just about shoot 'em up simulations or even flight simulations for that matter. It's about a lot of different ways to train and educate not only our uniformed military, but to educate folks like you. There is a big display here with TechPath and with some of the other science, technology, and engineering math opportunities. For those of you in Project Lead the Way, they have a big presence here as well. So there's a lot of really cool stuff going on, and we're really, really proud to be a part of this and to be able to bring at least a little bit of this to you in the classroom. So I'm in transit here, so I apologize if it's a little bumpy, but we're going to continue to move on. So We've got trainers for tanks. We've got trainers for aircraft, and we've got things that also have to do with understanding after you went through a little training event, you know, what you did, so that you could repeat it back to yourself, so you can learn from what you did and know all the mistakes you made and everything like that. So we're going to go into what is true simulation. So you can see right behind me that that's true simulation right there. Okay, and they're like I said, good buddy of mine, former test pilot as a rotor wing helicopter pilot with the Army, and he's going to show us a little bit of what he's doing with helicopter training. So I might end up taking the iPad off of this. We'll see. I'm going to try to work it out. But give me a second here while I open the door and go in and see my brother. Hopefully he's in there. There he is. How are you, brother? Good. Outstanding. Yep. Good deal. Good deal. This is Steve. We're going to be going. I can either pick up the iPad, Steve, and just carry it, or I can carry this over there to the side like you talked. However you want to do. Okay. So we'll do that. I'm going to go over here, so you'll see. Now, do they understand what ITSEC is? Yep. I gave them that intro of what it is and everything like that. So we're going to do our best to.
Not make me sound too stupid.
Yeah, exactly.
You'll edit out all the stupid stuff.
It's really hard to make him. So Steve, I'll let you hold this. Hold this.
Okay.
And, so you got a little bit of. Okay. You get that. We're not everything in the headset. Or you can put it in there so you're close to the mic.
Okay, and then what I'll just do? How about if I just use the light this way?
That's fine. Just a little bit. Yeah.
Absolutely. Just give me a couple seconds here. What do you, are you recording it?
It's on. It's broadcast.
Oh, okay. I like things cold. Okay. Just
so Steve is a retired Army colonel, and as I said, as I was walking over here, a test pilot, a very good friend of mine. So he does flying now to test out these simulators and make sure they're good to go for Bell helicopter and for true simulation.
Thanks, Roto. I appreciate the introduction, and everyone, ladies and gentlemen, I would like to thank you for taking your time to tune in to the station and be part of this, which is really part of the future. What we're involved in an operation called Operation Blooded Warrior, which it's a live virtual construct, and what that means is you've got animations, you've got simulations, which is what I'll introduce you to here, and then you also have live entities that are all networked together and brought together for training purposes, and you can work out all the command and control issues, you can work out all emergency procedures, and you can actually simulate a lot of what's happening in real life or what you project to happen in real life in order to train the crews and the entire structure. Where you're at right now, so it's kind of an interesting place. This is the V-280 Valor. It's a Bell helicopter aircraft. We're about 85 to 90% built on it right now up in Amarillo, Texas. We're partnered with True Simulation out of Goose Creek, South Carolina, and also out of Tampa, Florida. And they built essentially what is our engineering sim. And it is all fly-by-wire, much like folks probably do these, small aerial vehicles you can control with your phones and stuff like that. That type of work that you do now pays off huge dividends in the future. It's the same basic engineering applies all through it. You can look at, even your large airplanes fly off of that stuff. So this is actually our offering for the Future Vertical Lift, which is a program, tech demonstration program right now, funded by the Army and its joint program, Navy, Marine Corps, and the Army, in order to take what's next in the future. So hope time you folks study hard, stay in school, anything bad, get into college with this aircraft to be fully operational by then. What you're looking at is an aircraft slightly smaller in length out there, but it's got an airspeed of about 280 knots. It's got about 10 capacity on fuel, it's direction on payload, and it's pretty exciting. It's just a really exciting time right now. Roto, any questions on kind of base airframe thing? Absolutely. What we'll do is, in fact, I think you can just, there we go. You can just kind of, there we go, focus it on in. And one of the things that we've done with the aircraft, it's completely fly-by-wire, so you have side stick controllers, which is very good for a safety standpoint in the event of accidents or anything like that. Also makes ingress egress a little simpler when you have to do emergency type work because the stick isn't in the middle to trip over. You can see the dashboard this is a very, very standard type current technology dashboard because we can take the future right now twice as fast, twice as far as what you can do in your rotorcraft arena, and the aircraft or the vehicle itself is open architecture, so it's plug and play a lot like your Mac or your iPhones, things like this. So you can just plug in your technology as it continues, because everyone knows the technology makes exponential leaps about every 3 years. So you've got to plan for that, and you've got to have that open architecture. But this is a same mock-up as our demonstrator, and you kind of get a good feel for that. Should we go for a quick flight just so we can show the folks? Okay.
Sounds like a plan.
We'll see you real quick.
Okay. You bet. Steve's a funny guy. Trust me.
And where we're at, we're actually gently transported right now out to the correction, west coast of the United States. Okay, I'm just going to put this on. Okay. We're miraculously transported out to the west coast of the United States. We're actually at Miramar Naval Air Station out here, and what we're going to do is just do some quick takeoff and some quick maneuvers. So we are essentially a helicopter in this arena. So we have all of the capability that a normal helicopter would do. Hovering, we can translate sideways however we'd like to do. And one of the things you do notice, even though your body doesn't feel the motion of the aircraft has the motion, and you can actually make yourself a little seasick if you're not careful. So we've got this. This is actually a very nimble aircraft, what they call level 1 handling quality. So it's got a great capability to do pedal turns at a very, very high rate of turn, and then lock onto that heading when you would like. Now, if you take a look over your right shoulder, Roto, you can see the pylon over wing configuration. So that is actually the item that produces lift and thrust. And what I'll do right now is I'll just level acceleration. We'll do a takeoff. So I just start translating, programming the pylons forward. As the speed gains, the pylons will continue to move forward, and it converts from a helicopter into essentially what you have is a high-speed turbopropped airplane.
Awesome.
And in that arena, you are now flying an airplane, and we're accelerating beyond about 175 knots right now, so we're somewhere around 200 plus miles an hour, just that darn quickly. It is a very air maneuverable aircraft throughout the entire flight regime, and one of the things we can do with it is a lot of things that just weren't available to normal aircraft before, because I've got wing lift and rotor lift, wing lift, so we can just pull the nose straight on back. We're now currently climbing a little over 11,000 feet per minute. We can program the pylons up, and just that fast. We come up to altitude. We're still doing very nicely, almost coming into a hover. And there we go, just almost at the hover. There we go. And so what we did is, in less than a minute, we took off, we accelerated out to around 220 knots, zoom climbed up, and I'm sitting here at a hover at about 4,000 feet above the ground, which is just a tremendous capability for any of the air vehicles that we have out there. And conversely, we can go ahead and accelerate on down. She's fully maneuverable, even in the roll. And then a nice gentle about 3.5 G pullout at the bottom. And away we go. And we're the ability to accelerate, decelerate, and then have that low speed agility and actions at the X is just something that we've not ever had before.
Right. That's fantastic. When you talk about flying in combat, flying in really tough environments where there are bad guys and all that kind of stuff, it's that kind of agility of the aircraft it's actually makes it more survivable and makes the people in it more survivable.
Absolutely. It makes it a lot more difficult for folks to hit you. They're working, and with the higher speeds, they're working in a very small window of opportunity to do bad things to you, so you can blast through that. And it's just, I think it's a tremendous capability that's very survivable, and it's going to bring the nation a heck of a lot.
Yeah, you betcha. So Steve?
Yeah. Oh, that's scary.
Oh yeah. So any final thoughts on what these guys and gals ought to be doing to really be a part of something?
Absolutely. No, absolutely. It's an exciting time. You know, there's a lot of stuff you see in news. You hear about a lot of bad things out there, and don't even pay attention to that stuff. Just do the right thing. Be excited about the future, because it's absolutely unbelievable. And whatever sparks your interest now, follow it through, because it's a great world out there. It's exciting. The future is coming. You're part of it. The entire nation needs young men and women that are smart, educated, and driven to do the right thing. And God bless all of you, and I sure appreciate you taking your time today.
Yeah. Thanks a bunch, Colonel Kahara, who is, like I said, a good cadre of mine. We were test pilots together about 10 or so years ago, actually. And, he's a great American, and I'm really glad that he was able to take the time to talk to us today.
Thank you, folks. I appreciate it.
Thanks, Steve.
Yeah, you do too. You're moving. You should look at it that way.
So we're going to swap the camera back around, and we're going to get moving on our way here. But you can see this thing is huge. It's in a huge building. We're going to show it to you when we get on the outside. So we are really excited about being able to bring this kind of stuff to you. And we look forward to the next stop, where we're going to talk a little bit more about medical simulation. This you can see now as we come out of this building, a big building right there. That's the top of the building that this thing resides in. Okay, so it's a really good.
Use the other camera. Use the other camera. Then you can see where we're moving.
I understand. So so let's see. We're going to walk a little bit through here, and I'm going to show you a little bit of some of the other stuff going on. You'll see the. Sorry, it's all good. So we're going to go towards the blood and guts portion, for those of you that are into that sort of thing. But we've got great displays all over the place. So I'm just going to do a quick swing here. You can see that all the way down there, and then all the way down there are different booths with all kinds of different technologies and all that kind of stuff. So unfortunately, we don't have the time to be able to show you everything that we'd like to show you, but we are going to continue to this other side here with the Army Research Lab. So one other thing, and when Colonel Kahara was talking to you, I wanted to give you a little bit of I grew up in a trailer park in Key West, Florida, okay, and I wanted to be an astronaut based on what was going on right over here at the Cape. And that's the whole reason that I got hooked on what I was doing, because none of my family had gone to college, and I said, you know what, I want to be an astronaut. That's what I wanted to do. So we're going to continue, and you just, like Colonel Kahara, like Steve was saying, the bottom line is to not quit. Just be, you know, in my mind, I said, you know, I was just stupid enough to think I could do it. And so that's a big deal when it comes to chasing your dream. And I can't overemphasize that, as we walk through the floor here, that a lot of these people, they may not have wanted to do this when they started, but they learned in the process of what they could do, and they found their voice. So there's a lot of people doing really cool things, and we're going to head on to the medical simulation thing right now to be able to have these guys do a quick demo for us. If any of y'all have had an IV before, you know that the IV takes a little bit of time, and sometimes if they're not good at it, it can really hurt. So we're actually going to go see a trainer that does exactly that. So I'm looking for the guy that's going to help me here, and so if he's not immediately available, then I'm going to, but I want you to take a look real quick at this here. Well, we've got, look at this here. So we're going to have somebody, Mark, good to see you. Outstanding, thank you. So if you look at this, if some of you don't know because you haven't had to see muscle up close and personal, but right there, that's fascia that's on the outside of the muscle. And that's a trainer they actually have to go through into this muscle right here and tear this up and actually address issues with the muscle tissue and that sort of thing. So, and there's all kinds of different emergency procedures that have to be done in the battlefield that you can't do. Doing it the first time in the battlefield is absolutely difficult beyond words, because you can imagine you're already in shock, you're already kind of having to deal with this kind of trauma, but you need to save, you have an opportunity to save somebody's life. So that's the thing that really matters at the end of the day, is being able to save lives and improve what they call medical outcomes, given the fact that you don't have a lot of time. They call it, they actually call it the golden hour that you have between this time where there's an injury and that sort of thing to a time where you're actually going to be able to survive. So, are you giving the narrative of this at all? Jack? Can you talk? Fasciology a little bit? Just you don't have to.
It's better if you do. Better
if you can. And just talk a little bit about this trainer here and what it's supposed to be doing.
Hello, my name is Jack Norfley. I'm with the Army Research Lab. I'm the Chief Engineer for the Medical Simulation Research Branch. And what you see here is one of our early prototypes. We're moving into the world of surgery. The Army trains surgeons, advanced medics, special forces medics to perform this surgery to try and save the leg or limb, eyesight, and life of the soldier. Typically, it's life, limb, eyesight in that order of priority. So they came to us as a researcher and a developer of medical simulation for training for a device where they can give their trainees hands-on practice so they can become proficient in a pretty scary procedure, and one that they might have to do in the field. So our primary goals with this simulation are to recreate the tissue properties, make sure that the anatomy is spot on so that when they're feeling for their landmarks on the outside, they will know that they're cutting in the right place, and they can practice it over and over again so that when they have to do it for real and their buddy's life is on the line, they'll have done it 100 times and be good at it. And that's what we're trying to give to them. So proper anatomy, good tissue properties so that the look and feel is right, and more importantly, the forces that they use. We can't have them jabbing the knife in there to cut through skin that's unusually tough. It's got to react similar to human, so that they'll be using similar forces and performing the procedure. We also the anatomy is important in that not only is it important to know where to cut, it's probably more important to know where not to cut. So we have nerves in here, we have vessels in here, we have areas that they should never get into, but from a learning standpoint, we also have to determine or give them the areas that they must enter to properly treat this problem. The procedure that we're teaching is a 2-incision, 4-compartment fasciotomy to relieve a condition known as compartment syndrome. It's typically when there is trauma to the inside of the leg, a closed trauma, that can happen either from an IED or, this is not uncommon with long-distance runners and with soldiers who carry heavy loads over long distances. What happens is the tissues inside the leg will start oozing or secreting fluids. The muscles are held together by these really strong fascia. It's a tissue. Any of you who've ever run into really to gristle while eating a really tough steak will know what I'm talking about. Well, what happens is this fascia will not bend. So you're building pressure inside an enclosure, and if you don't open that enclosure and relieve the pressure, it will build to a point where, one, it'll cut off the blood flow, and two, it'll start damaging nerves. So at a minimum, you start threatening the health of the leg. If it goes farther than that, then it starts threatening the health of the patient. So it's a fairly brutal but usually effective procedure that we're training. And so we're training it out in the field, because many times with special ops, they'll be 72 hours from being able to get their casualty to a patient. They might be on a mission where they can't bring a helicopter in because it'll tell the enemy where they are. Or it might just be weather or enemy positions or some other reason that they can't get this guy out to a hospital, so they have to do it themselves. And we owe it to them to give them the tools to practice it, so that when they have to do it, they have the confidence and the ability to do it properly.
Thanks a lot, Jack. Appreciate that. As you can see, guys, that's a really a procedure that would be hard to do the first time live, okay? Because you really are doing things that are sort of unnatural to you, and so you don't want to be doing that for the first time in a live environment with all of that trauma and all of that kind of stuff. So we're going to show another trainer here. And hopefully none of you have had to have a tracheotomy, but you know that you've seen it on TV and all that kind of stuff, that it's a very, very important thing in keeping people alive. So with that, Mark Mazzeo is going to talk a little bit about that.
All right, good afternoon. I'm Mark Mazzeo. I'm an engineer here with Army Research Laboratory. And as Jack was mentioning, what we're very interested in here, especially with these kinds of medical interventions, is tissue properties. We know that the human neck and the throat feels a certain way. And if you feel your own throat, you can kind of feel that a lot of it kind of moves around. A problem that we've encountered in a lot of different training devices is that a lot of these portions of them are very rigid, very stiff. And we've tried to correct that with this device that you see here. So this is a full airway management training system. You can do a tracheotomy, which I can describe in just a moment. You can also do nasopharyngeal airway. You can insert a tube through the nose, and you can actually thrust the jaw forward and do a full intubation. So back to tissue properties. So the way that we try to remedy the problems that we're encountering is we're going to basic science. We're looking at different mechanical properties, such as the stretch ratio, elasticity, things like that, of a variety of different types of simulated materials that are currently commercially available. And we're actually comparing those to human tissue. So what we're doing is we're taking data from human cadavers. Since this is for military applications, we're most interested in cadavers of individuals that could have served in the military. So ideally people between 18 and 50 years old, roughly. We compare the mechanical data that we've collected from the human tissues, compare it to synthetic tissues. And what we've seen so far is that there's a tremendous difference that we still need to overcome. So what you see here is a first stab at trying to correct that. This fixes it anatomically and physiologically. So I don't have a tube here that I can actually intubate with, but what I can do, I can actually use this device and go down the throat, but I think I have to change. So if you give me just 1 second, I'm going to go press the button.
So he's going to grab a couple of pieces here. And it's hard for you to touch this, but if you touch it, you would realize that it feels very, very realistic. And obviously, that's part of the training, because it needs to be realistic in order to make that happen. So this is a rendition of what it really is. Is that what's on video
now? Okay, so what we have here, I have a video laryngoscope. And what you're going to see when I go down here, I'm going to push his jaw forward, and there's a camera at the tip of this, so you'll be able to see inside here. So I'm going to give it a shot and see how far we get. So the tricky part of doing this is trying to get past the tongue. I'm going to try to stick my finger down there just so I can kind of feed this down. But as you can see, if you look at the big screen right here, this is very, very realistic. And what you have to try to do is get the tip of this blade past the tongue, push the tongue out of the way, so that you can actually expose the vocal cords. So you can see right there, that is an epiglottis, or that's the, yes. And if I lift this up, if I get it just the right spot, you can see the epiglottis right there. And if I push just ever so slightly up, I can fit a tube down into the open part. And I know I'm in the right spot once I can identify the vocal cords.
That's awesome.
So that's just a peek inside the anatomy of this. So as you can see, we've really tried to make it as realistic as possible. And there's actually the vocal cords. You can see right underneath there. Yeah. Yeah. So that is our airway simulator.
I don't know, looks like a guy needs mouthwash.
Yeah, perhaps. All right.
That's fantastic. Really appreciate that.
They can't hear you.
Oh, okay.
Anything else you'd like to offer to the kids before we move on to the next phase?
No, I think that's about it. I studied industrial engineering. I went to the University of Central Florida.
Go Knights.
Yeah, go Knights. I did not expect to be doing anything medical related, but you never know.
You work for the Army, right?
Yes, I do work. I work for the Army.
Right. And where did you grow up?
I grew up just outside of Orlando in a town called Melbourne.
Excellent. And how long have you been with the Army?
Just since 2012.
Okay. You're relatively new.
Pretty new, yeah.
Well, thanks so much.
All right. No problem. Thank you.
Thanks.
So I hope everybody's liking the gory stuff because, there is some of that here at ITSEC. So we're going to roll on, and it's Colonel Harry Buell. Say hi, Colonel Harry Buell.
Hi, Colonel Harry Buell.
Yeah, he's actually responsible for the whole agency that does this this whole research, the Army Research Lab that does all this human performance stuff and everything like that. A great American with a capital A. So, Teresita, it's great to see you. So we're off, and we're going to go to our next step here, but thank you so much for the opportunity. Really appreciate it. So, you can see we're going to walk here, and the floor is hopefully a little bit smoother here, so we'll try to keep it from being too shaky, and we'll stop at places that makes sense to stop at. Trying to give you an appreciation for what we've got here at ITSEC. Now, if you think about what you just saw, that's not the kind of stuff that's just for the military, right? So many of these technologies that you see are technologies that are although maybe developed by the military, they're going to make your life better day in and day out. Because if we can improve our health care through great training, that affects everybody. Okay, and so the kinds of technologies that go into these things, and to make human tissue type skin that you can train on, that seems so realistic, it's like you're actually there. In our world, we call that the suspension of disbelief. If you've gone into either an IMAX movie or you've gone into something that's really been immersive, where you felt like you were part of the whole thing, that's the kind of thing that we try to create in the training world, so that you no longer believe you're being trained, right? You believe you're actually there. So all of the emotions and all of the nervousness and things like that come into play when you're actually doing your job, you start to see that and start to feel that, and that affects your performance. So we want to make sure you feel that in a real good training environment, instead of feeling that when it's like really happening. Now, in my case, I landed on aircraft carriers in the F-18, and I can tell you that there was absolutely no way they could recreate how scared I was in an F-18 trying to land on an aircraft carrier at night. there was no way they could recreate that until I actually had to do it. Okay, but once I did it, and then I had gotten that scared done, I actually relied a lot on the stuff that I learned in training so that I didn't have to pay attention as much to that as I did about just being scared. So anyway, fortunately I survived, and so many others day in and day out right now are landing on aircraft carriers all over the world, and I can tell you it's a phenomenal experience. So you can see some of these demonstrations are amazing, and a lot of it has to do with things that you're very familiar with. Virtual reality, there's a lot of goggles, the 3D kind of stuff here. Here's a different version of that trainer that you saw, but this is actually not a flight trainer that you're looking at in the middle of your screen, and I didn't talk to these guys in advance, but that's where, if you think about somebody that's on a hill trying to call fire in for somebody that's going to be in harm's way, that's the kind of training they need to make sure that they can talk to the airplanes, that they can do all the kinds of things that they need to do to make sure that that mission goes off successfully. So we're coming a little bit more towards the end of our time together, but I want to just take you through a little bit more of this stuff. And again, if you're not going to be here on Thursday, or if you are going to be on Thursday, if you're not here Thursday, please come next year. And the teachers will make sure you get the information you need in the time that you need it to be able to get the approvals you need and everything like that. Unfortunately, we do have to limit somewhat the number of students that get to be here. So, I recommend that process be somewhat selective, and that people, in order to be in an environment like this and to be able to learn all of the things that are available, and have yourself kind of talk to some of these people that do this day in and day out, and realize that they're just like you. Okay, they're people that were just like you, and the same kind of thing as you, same kind of background as you, and often decided that, after making a couple of mistakes, trying to do some other things, they decided to do this. Not all of them, trust me, not hardly any of them, if you ask them when they've been doing it for 10 years, if this is what they originally wanted to do when they were in high school, would tell you, yeah, I wanted to do it all along. You don't have to get it right the first time. You just got to keep working at it, kind of like Colonel Kahara was saying. So we're going to go through and see a couple of more of these things, and you can get an appreciation for what's on this floor, and then we're going to finish it up back at the Navy booth where we started. Okay, so a lot of you have heard of Northrop Grumman. Okay, a lot of you have heard of Northrop Grumman is a big company, right? They have a big presence in Melbourne, and they have a big presence all over the world, actually. But they build a lot of things, including a lot of those unmanned systems, the UAV airplanes and stuff like that. And they actually built the very first unmanned airplane that landed on an aircraft carrier. So very big accomplishment. But hopefully this has given you an appreciation for the massive scale of ITSEC. Anywhere between 16 and 20,000 people will be here, and everybody from exhibitors to people that are trying to do business here, and as well as the military trying to figure out, okay, what can we do to better train our forces and make sure that we're actually still in the lead as a country, and that nobody wants to mess with us. Okay, and that's spoken like a Navy guy. But so I don't know whether or not, I'm going back to the home plate right now, but we're going to check and see whether or not we got any questions, and we'll be able to answer them with a little bit of time that we have left. But we really appreciate y'all playing, and hopefully this was interesting to you. And I would ask the educators, please give us feedback, because this is the first year we're doing this, and as with any first year, there's growing pains associated with that, and things to learn associated with that. So we're going to continue to learn by doing, which is what you heard Colonel Kahara say too. The only way to learn is by doing. You heard Commander Thomas talk about that with respect to the first thing you saw, the multiple reconfigurable training system. Okay, so I'm going to stop right here and check with our folks back in the HQ, and we'll see whether or not we've got any questions, and feel free to offer them up, and we'll be absolutely happy to answer them. Okay, we're going to focus this on the Navy booth for now, so you can see that in the broadcast. Do we have any questions?
We done?
Okay, super. Well, hearing none, okay, we're going to give you back 9 minutes of your time. to enjoy the rest of your day. We appreciate you joining us this afternoon, and please tell the others that this is going to be an event that we will do in concert with ITSEC every year, and we'll put out those requests and whatnot, and put out those emails the same way we do the student tour stuff. So with that, we're going to go offline, but make it a great day.
You know, it's 1400.